Hello everyone, this is the next part of tutorial videos. In the last part we have finished with basic user interface for our inventory. And today we're gonna add objects to our inventory and we'll try to display them. So let's open our inventory system. And first, I have added a little bit for interactions for my future and I don't think that we'll use it. I will record it. So let's create a function and call it, first let's call it can add item to inventory. An input is gonna be item of type BC container item. BC container item. Well, what this function will do, it will have to check if at least one container from our getAllContainerItems function result have enough place to store this item. Well, but let's open our item, BC container item here, and add a function. Let's call it has place for item, or maybe not for an item, has place for item. Input item BC container item. Well, here we're gonna get dimensions from this item, or maybe not here. No, we're not gonna add some logic into container item, at least for now. So let's delete this function from here and add this function to our component. So let's call it has place for item in. First parameter is going to be item. Second parameter is going to be container. So what we're going to do, we're going to get dimensions, well, I don't have a function for dimensions. Okay, let's open BC container item and add function. So I'm gonna copy get thumbnail, call it get dimensions, and return, instead of thumbnail, I'm gonna return dimensions. And do the same for container rows, get rows. Oh, we have get rows. So that's it. Let's go back to our component and let's call get dimensions from our item. And from our container, we're gonna call get rows. Now we're gonna loop through each row and check its cells. So we're gonna loop through first row and check if this cell can store this item. If not, then maybe this, maybe this, maybe this, and so on. So let's break a row and we have a cell. Let's create a function now. And this function will check if cell can store an item. So let's call it has place for item in cell. And let's rename it in container. Has place for item in cell will have almost the same parameters. First is gonna be item. Second is gonna be cell of type BC container cell. Well, here we're also gonna get dimensions from our item. And from a cell, we gonna get, what can we get? We're gonna get dimensions. No, not that. Yes, we can get dimensions. So we're gonna get dimensions from a cell also. And first thing that we have, first condition is gonna be if size of a cell is bigger than dimensions of an item that we want to store. So we're gonna check if get dimensions of cell are more. We, we can't. Okay, let's split it. So x is bigger than or equal than item x, and y is also bigger than item y. And both of these must be true to store. So if false, then we're gonna return output a result of type boolean. If false, then we're gonna return false. So in other case, our cell may have an item in some place. So the logic will be like this. We're gonna loop to the first cell and check whether we can store our item starting from this one. Like if we're trying to store a magazine here, we're gonna check, can we store it from first cell? So we will check if this cell is empty and this cell is empty to store it. And for example, here, if we will try to store it in this cell, it will check first cell is empty, but dimension of a magazine is 1 per 2, and it will check a next cell. It will be not empty, so it will return us false. Now we're gonna get dimensions of a cell. Again, break it. Here, let's add a for loop on true. And we're gonna check from a first cell. So we're gonna check from first cell whether it can store it from this one, like for example, tuple3 object is gonna check if it can be stored like this. If not, then it will go here, check if it can be stored like this. If not, it will go here, check if it can be stored like this, and so on. So it's gonna be a for loop with that starts with y. First index is gonna be y0 and y minus 1 as last index. And here we're gonna also have a for loop. For loop. And first index is gonna be 0 and the last one is gonna be x minus 1. So we're starting from y and ending with x because we want to loop not like this by columns. I want to loop by rows. So I want to check first row first. So at y0, but all x's. Then y1 and all x's, and so on. It really doesn't matter in which how you will place them, but for me it is easier to understand what I'm doing. Okay, now we have to check if at these indexes if from this index we can store an item with our dimensions. So let's promote to local variable our local y and this variable to a local x. Let's set it like this. And here we're gonna get an item, get item. And we're gonna get dimensions of our item and split it. So for example, now we are in cell 1 and dimensions of our item 2 by 2. So we're gonna get this local x and y, which are 0, 0, And step by step, check if this one empty, this and this. So we're gonna add for loop from 0 to a dimension x minus 1 to the last index, and again for loop y minus 1 to the last index, and check if newly created index, newly created x and y is valid for our cell, and if our cell doesn't have an item at this index. So we're gonna get cell, and first index is gonna be local, we're doing x, local x, and here first index is gonna be local y, not just 0. So now we're gonna get a cell and get items and check if item at index this, we should add 1 to this, multiply them, subtract 1, and this is gonna be our index. So now when we have an index, we can check if item is valid at this index. So we're gonna check if index is valid, if this index is valid for this array. So it is in bounds of array. Well, boolean check if it is valid. If it is not valid, then we're returning false. So that means like we're trying to store something that is out of bounds of an array, like we're trying to store our magazine on the last slot of our backpack when there is nothing lower. Well, in another case, if it is valid, then we are going to check if an item at this index is not valid. If it is nothing, check if an item valid. Oh, get. We're gonna get an item at this index and check if it is valid at this cell. So if it is, then we cannot store an item from this local x and local y. Let's create a new variable and call it local valid of type boolean, and by default it is true. Let's add a branch. So if an object is valid, we're gonna set local valid to false, and we're gonna change our local x or local y to the next index. So we're gonna break from these loops. That means that, for example, this slot was empty when we have tried to store our body armor. This slot was empty, this slot was empty, but this slot wasn't empty. For example, grenade was lying here. So we checked this is true, and this is not. So we're breaking and starting to check from this index. So let's replace this for loop, this one, for to for loop with break plug it here. This goes to last. This goes to first. And index goes here. Okay, so if it is valid, then we are returning from this. Then we're breaking from this loop and starting to check. We're breaking from here. If false, then we're just continuing to check. And if we have completed this loop, and if we have completed check and we never passed here, and so local valid is true, so we're gonna get local valid and check if it is true. Oh, we can just plug it here. So if we complete it and local valid is fine, then we can return. Then we can tell that we have found the correct place with the result true. And also I think that we have to pass local x and local y here. So let's add x and y. So plug local x, local y. Compile and save. Now, also maybe let's move them up. If false, then we're doing nothing, and we will return to this array. It will check everything, and finally, if this loop is finished, then we are returning with false because nothing was found. Also, we have to set it back to true every time when we are looping at this loop. So we're gonna set to true here. Well, it may be complex, but looks like it's all. Has place for item in cell. We have implemented it. Now let's navigate back to has place for item in container. So now we're gonna loop through each cell. For each cell, we're gonna call has place for item in cell. Cell and item is gonna be get item. If true, then we can return from this function with cell and index. We can just name it index. And cell is going to be BC container cell. If true, then we're going to multiply x. No, we're going to x plus 1 and y plus 1 multiplied on each other minus 1. This is going to be an index. So for example, this one is going to be 1, 2, 3 multiplied by 2 minus 1. Okay, this is going to be 3 by 3. Okay. And cell is going to be this cell. Now let's implement can add item to inventory. And here we are getting all container items, and for each of them we gonna call has place for item in container, and item is gonna be get item. And if true, then we're gonna add the same return node as has place for item in container. I'm just gonna copy it from here, paste it here, and it also will return us a container. Container of type BC container item like this. So cell to cell, index to index, and container is this one. Oops. Okay, okay. So now we have function can add item to inventory, and let's create function add item to container. Let's make it private. Let's add an input. First container, item, and index. Integer, and here is gonna be BC. Okay, container item, and also cell. Cell BC container cell. Let's move it. Container cell item. So what we're gonna do? We don't even need a container. I think we need only cell. So we're gonna get an item and get its dimensions. Split it, and we're gonna loop for loop from 0 to x, and the same for y. And we're gonna get cell. We're gonna get items. And we're gonna set array element at we're gonna add 1 to this, 1 to this, multiply them, minus 1, add them to this index, plus this index, and then it goes here. And we're gonna get items that we want to add. So it will add, where is it? For example, it will add grenade only into one slot, but if we will try to add a body armor, it will add a body armor here, 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 here. It will be one object at 4 slots, but it will be one object. We're adding it to each slot so that in future we will know that it takes this, and this. So we have added an item to our inventory. Well, also I have made this function private because we're gonna call this from event graph. From an event, we're gonna add custom event and call it add item to inventory. Let's call here add item to container. Plug, we don't need container, we need only cell, item, and index. Let's unplug it. If you're not writing a replicated project, then this is enough for you to work. In case of replication, we have to do it only on the server side. So we're gonna call server add item to inventory. And we're gonna call server add item to inventory, cell, item, index, select add item to inventory, replication run on server, access specifier private, and from here we're already gonna call add item to container, cell item index. So now our inventory will store an item. For debug, let's oh, I'm not sure. Let's continue. So now we have to get items from somewhere. Well, let's do that. Let's let's make a simple item. I have created interaction folder and created a test actor with a static mesh. Also, let me delete this. So this is a test actor with a static mesh. Add a sphere collision here. Scroll it details till collision. And in collision presets, select custom. Collision enabled, select collision enabled, ignore everything, and it should block only visibility channel. Well, we're using visibility channel because, and not a custom channel, for example, because, for example, if in my house an apple will lie here, and we are using a custom channel that is only blocked by interactive objects, then a player will be able to interact with it through a wall, because wall will not block my custom channel, but it will block visibility channel. So we have added it, and now let me remove this. Let's navigate to initialize function, and at the end of this function, do it only if you're writing a service replicated application. If you're not writing a replicated application, then you don't have to create a variable here. Create a new variable called locally controlled of type boolean. Here we're gonna get a character and call locally is locally controlled and set it to this locally controlled boolean flag like this. Next, open event graph and add event tick. That's already for everyone. Everyone should add event tick. And we're gonna call some functions that will trace something. I have already created it, but I can, I will delete it now. So we have to create a function. Let's call it trace interactable objects. Let's put it into a category called interactions and make it a private function. Open event graph, and in event tick we're gonna call this function. Also, for if you're writing a replicated project, we have to check if this component is owned by characters that is locally controlled. If it is true, then we're gonna trace interactable. We're doing that because we don't need to trace this on the server or any other players that are on the map playing with us. They don't need to do this logic. It will require resources from PC that are not needed. So now let's open trace interactable objects and we're gonna do a line trace. Let's call line trace by channel. Here we have to provide it with start and end. Start is gonna be a camera location. If you have your camera attached to a character, then you can just drag character here, get camera, and so on, and get world transform. In my case, I have camera manager, so I'm gonna call get camera manager, get transform component, and gonna get world transform. Get world transform. So here we can split this world transform, and this location is gonna be our start location. Next we have to find forward vector from a rotation. Let's call forward vector multiplied by, for example, 2000. Right click on second vector and click to float 2000. It's gonna be a length of our trace. You can change this value as you wish. I want the trace to be long enough. And I'm gonna add this to a start location. And this is gonna be an end. Well, next, we're gonna check if it was a hit at first. So add a branch, check if it was a hit. If it was, then we're gonna break hit result and check if hit actor is valid. Well, currently we are writing very simple interaction logic because this tutorial is not about interactions, and this is only for test purposes. Here in normal project we have to have a lot more conditions and depending on your interaction system. So we hit an actor and we have to check whether we can store it in an inventory. So how can we do it? We can create a new actor component like blueprint class, actor component. I have already created it and called it BPC interactable object. And let's open it up and add a new variable here. And let's call it item of type BC container item. Make it single and that's it. So now in our component of inventory, we checked if hit actor is valid. Next, we're gonna check if it has this component. So we're gonna call get component by class BPC interactable object, for example, this one, correct. And check if it is valid also. Is valid. Well, if it is, then this object is interactable. And now we are only doing a picking up. So in this case, we're gonna get the sector and destroy it, for example, or no, we're gonna check if we can store this actor in our inventory. So we're gonna get this actor, get this component, and get an item. We're gonna get these items that we have added to this component. And we have to check whether we can store this item in our inventory. So we're gonna call can add item to inventory. Well, this will be a little bit heavy because we're doing it every trace. In normal project, you should do it only if you're tracing interactable object and, for example, touching F keyboard button. But now for test purposes, we'll do it like this. So if we can add this item to an inventory, then we're gonna get this hit actor and destroy it. And after that, we're gonna call add item to inventory event, not a function, event, cell, item, index. What is an array element here? Can add item to inventory. What is it returning? Get all containers. It returns as a container. It is not needed. Delete. Okay, and let's test if it will disappear. It will not because I didn't add this component to my test actor. So click add and add BPC interactable. Oh, I'm not sure which one of them is this one. Also, we have to provide our, for example, apple with an object, with an item object. So here we're gonna open a construction script, get BPC and set item. And construct object from class of class BC container item, plug it here. So now we have to provide to give a details of items that is associated with this object. In my case it is apple, so it will have name apple. It will have dimensions of 1 per 1. No thumbnail, no rows. Compile and save. So now let's check. Where is apple? No, that's not that apple. Where is it? I want to start here. So here it is. It looks like it already appeared in my inventory. Let's double check. Let's open inventory component and change its dimension to, for example, 2 per 2 and spawn 5 apples. So it should store only 4 apples instead of 5. And maybe it will be lagging. 5 apples. Start here. Oh, first. Oh, we stored 5 apples. By the way. Interesting situation. Oh, why can add item doesn't return us a boolean value? Has place. Well, in our function has place for item in container, we're not returning actual result, like can we store an item. So let's add an output, call it result, type boolean, and in case of true we're returning true, in case of false we're returning false. That's in has place item in container, and in function can add item to inventory, we also should return a result like this. And now in trace interactable objects we need to check if result was, if we really can. If true, then destroy actor. If false, then we're doing nothing. So let's test it again. Where are our apples? So first, second, third, fourth, fifth. So to fix this issue, open BC container cell and add a function set item at index that will look like this. It will get an input of item and index. Item has type BC container item, and you have to change an array here. And in your component, in function add item to container, here instead of set array element manually, make it look like this. So get cell, call function set item at index, and pass item and index. So now I'm gonna remove a breakpoint and run a project and try to collect 4 apples because 5th apple is still added. So now I'm gonna add a breakpoint here and add breakpoint here and try to collect 5th apple. So now we can look how our container looks like. So it has an item 0 slot, first, second and third slot. So all of them are busy slots, and for some reason it still tries to add an item at index 1. So looks like has place for item in container fails. And we can, where is call stack? Okay. We cannot add item to container. No, now let's turn it off. And well, unfortunately, I've made a mistake during computations of an index. So to fix it, open a function called hasPlace for item and cell, and it should look like this. So first, here on first for loop with break, last index should be x minus 1 plus local x. For second loop, the same, but with local y. So dimension y of an item minus 1 plus local y, and it goes into last index. Next, to compute a final index in array, we need to multiply a result of for loop on y on dimensions x of a cell. So we are getting a cell, getting dimensions, getting x, multiplying it on the result of this for loop, and adding it to an x. Well, after that, we're doing all the same stuff. Next, we have to change computations of an index the same way in hasPlace for item in container. So here, in this function, after hasPlace for item and cell, we are changing everything that has been written here to this. We're getting dimensions, x of a cell, multiplying it on y, and adding it to an x. And this is the result index. So now, if we start, 4 apples are collected and only 5th is placed here. So now let's go to a visual representation of these items. So let's open a user interface. Well, so let's start. I have crashed, and first we have to create a user widget for an item that we are storing in our inventory. To do that, navigate to a folder where our widgets are located and create a new user interface widget blueprint. User widget vb container item. Let's open it up. Let's add a canvas panel. No, not a canvas. Let's add a size box. Set width override, height override, and instead of fill screen, set desired. and set width and height to 100, for example, for now. And our items will have a small name somewhere and an image. So let's add an image. We have to add an image into size box. Let's add a paddings on 1 pixel from a borders of our cell. And this is going to be an image of an item that we are adding. File save. For now, it's going to be just white. Oh, no, let's make it black. Or even red. Not this. I'm sorry. Color red. And let's put a text. Or we cannot. Right click on an image and wrap it with overlay. Where is overlay? Select image here and scale it horizontally and vertically and add a text into an overlay. Well, align it to the right side and to the top. Align text right. And let's write something like Apple. And change its font from, let's make it bold, 12, 11. 11 is fine, and add some paddings, 3 from top, 3 from right, like this. Let's name it txt item name, make it a variable, select an image, and name it emg thumbnail, make it a variable. Also select the size box, name it sb size box, make it a variable. Compile, save, open an event graph, add a variable called cell size of type float, and item of type container on BC container item object reference. Both of them should be instance editable, exposed on spawn, private, and item also. Well, delete everything from event graph and add event initialized. So what we're gonna do here, we're gonna get an item and get its dimensions. Split it and multiply x on cell size, multiply y on cell size, get a size box. Also, don't forget to add a delay, 0 seconds. Set width override, and width is gonna be x multiplied on the cell size, and set height override, respectively. So now we're gonna get an image, thumbnail, set brush from material, and get an item here, get icon, no, get thumbnail, just get thumbnail, and plug it into material. Next, we're gonna get txt item name and set text. Again, get item, get name, like this. Okay, so that's all for now for our container item. And we have to be able to draw it in our container cell. So let's open our container cell widget. That's it. Open graph, and we have to add our widget. So open event graph, and here on initialized, let's create a new function and call it, well, how we're gonna call it? We're gonna call it draw items, and we're gonna call it after initializing, like this. So now let's draw items. We're gonna get cell, get items, and for each of the item, for each of them, we're gonna check if it is valid. So first, we're gonna check if an item is valid. If it is not, then we're doing nothing. If it is valid, then we have to create widget of type vb container item, plug item, and plug cell size. Well, now we have to position this item at correct place. So how do we place it at correct place? We're gonna get set position. No, get slot. Oh, we have created it, but we didn't add it. So we're gonna add it into in our cell border. We have to have a canvas panel so that we will be able to add something into this canvas panel. Add the canvas panel, set paddings to 0, call it somehow like cp items, and make it a variable. Now we're gonna get cp items and add child to canvas. Well, this will return us a canvas slot, and we can set position on the canvas slot, but we have to know what is a position. Well, the way we're gonna do this, we know array index, and we know a cell dimensions. So let's get dimensions of a cell, split it. So we have created an index using dimensions. Now we have to we have built an index from x and y using dimensions. Now we have to reverse it and create x and y using array index and dimensions. So what do we need to know? We need to know y. So what we're gonna do, so we are dividing this on y, and that's gonna be a y index. And to get an x index, we're gonna multiply this by not cell size. We're gonna multiply y index on dimension x, and subtract this from array index minus, and this is gonna be x. So this is gonna be y, this is gonna be x. So let's promote to local variable, local x, and this is gonna be local y. So now, using local x and local y, we're able to find a position. Let's split it, and x is gonna be local x multiply on cell size, and local y is gonna be, and y is gonna be local y multiplied by cell size. I hope. So now, so To be able to draw in items, we have to be able to get them. But currently, we cannot get them in a normal way because, for example, an item that takes 2 slots will return the same item for this slot, the same item for this slot, but we have to be able to return them as one single item. So let's create a new function in our inventory component and call it get all items for, I don't even know, for maybe for cell. Yes, because we have to draw them only in cell. So get all items for cell. What we're gonna do here, let's create a local variable and call it local items of type bc item bc container item object reference and make it set so that they are not repeated. Now what we're gonna do, we're gonna add an input cell bc container cell. So for this cell we're gonna get items, and for each well, it will not save us an index. So it should not be just a set, it should be a map item index. And for each of them, we're gonna check whether local items find already contains this element. If false, then we are getting local items and adding, or if false, then we're adding this item to this map and providing an index. So map cannot have equal hashable values by default, so every item in map will be different and every item in map will contain an index of an item in a basic array. So, and after a loop finished, we can return this map. We can get local items, move it here, and rename it items. Okay, so here we have a function that will return us needed items. Now let's open our container cell in user widgets, and it has to know about inventory component to be able to call this function. So let's add a variable and let's call it inventory component of type bpc, and depends on how you have called it. Make it instance editable, expose and spawn and private. Copy it, open that's container cell, open container row, paste the same variable here, open event on initialized, and we have to refresh this create widget, and it has new pin inventory component, and we have to plug this inventory component here. Save, compile. That's for container row. Next, what is above container row is WB container. Open event graph and paste component here. Open on initialized, refresh if it is not refreshed by default your container row widget, and plug inventory component. Save, compile. Now what is above container is inventory by itself. Event graph, find the place where a widget is created, refresh it, inventory component appears, and here we can plug an inventory system. Now we can close this and navigate back to our container cell, to the function where we are drawing items. Now, move everything a little bit to the right. Instead of drawing every item, we're gonna get inventory component and call get all items for cell function. Plug in cell, and here we have an items, so we're gonna get all get keys, just keys. Yes, we're gonna get keys and a loop through keys. And instead of using an array index from here, we're gonna get find an element in our map here, and it will return us correct index. We can plug it here, we can plug it here, and that's all. So now let's test it. Maybe it will work. Where is an image? Image is red. Overlay. Size box. Well, it looks like it is drawn incorrectly. It looks like its size is incorrect. Let's add a breakpoint here and test it again. Height 100, width 100. Well, how? Cell size is 50. 2 per 2. Okay. Okay, so it should be working, but it doesn't. Maybe problem is with setting an empty material. No. Here is our canvas panel. So maybe we have to add some offsets, for example, position Y plus, what if I will add 50? How will it behave? Change to nothing. 100. Oh, didn't plug it. Plugged it here. 50. So the problem is with size. So we're getting it as a canvas slot. What if I will write here set auto size? Okay, looks like now it works better. So let's open an apple and change its dimensions back to 1 to 1. Yes, we have apple. Let me pick two of them. We have two apples now in our inventory. So they are drawn. Well, I'm gonna change a thumbnail for an apple to, I think that I have a material instance apple, like this, so that it will be drawn easier to understand what we have in inventory. Okay. So that's it for this video. We will context in the next one. Thanks for watching.